I'll teach you everything you need to know about numeric for loops in 5 minutes. The loops we looked at before, the while loop and the repeat until loops, they're great for when you want to repeat something until a condition is met or while a condition is met. However, if you want to repeat something a certain number of times, for that we can use a for loop. Let me show you the syntax for that. First, start off with writing for, then you write I equals, and now there's going to be two numbers, a starting point and an ending point. Let's do 0, 10 for now, and then you write do, and when you press enter, the end will appear. Anything we write in between the for line and the end line will be repeated. So whatever we do inside the for loop, it's going to start counting at 0 all the way up to 10. So from 0 to 10, that's 11 because 1 to 10 is 10, 0 to 10 is 11. So let's go ahead and run that, and you can see it prints out something 11 times. That's basically how a for loop works. You want to start somewhere, like start at 1 and go up to 25. The first number is the starting point. The second number is the ending point. So from 1 to 25, there are 25 numbers, so it'll do this 25 times. Something useful you can do with for loop is using this I right here. It doesn't have to be I, it could be any, for example, it could be a count, like you can be whatever variable you want. And then we can actually print that number or use it in any other calculation. I'll just print it for now. And you see, it goes from the starting point at 1 and it goes all the way up to 25, the ending point. And yeah, we could even like wait half a second. The count is going to be equal to 1 because that's the starting point. It's going to wait half a second, print out 1, and then go to the end. Oh, we have to restart because we're not at the 25 yet. So now count is equal to 2. It's going to wait half a second, print 2 because it's equal to 2. It's going to go back to the start. Count is equal to 3 and so on until it gets to that ending point, which is 25. You see it waiting and printing. It's really simple stuff. And it'll keep printing all the way until it reaches to 25. Like I said, this could be anything. I just like having it I, and that's probably the standard thing you'll see. So let's just keep it like that. Remember in the other loops I told you that if it's a big number, you need to add the weight. Yeah, same thing for here. If you want to print trillions of stuff at an instant, your computer's not going to be able to handle that. So it's going to crash. So make sure to keep that weight if you have an unreasonably large number. Apparently, the for loop just crashes you with the error message didn't come to save me. I don't know. I didn't know that was a thing. But anyways, let's go back to what we were doing. Let's go back to printing the I value. And something else you can do is if you add a comma and a third number, you can change the increment to whatever you want. For example, if you make it equal to 2, it'll start at 1 and count by 2's. You see, 1 plus 2 is 3, plus 2 is 5, plus 2 is 7. And yeah, you can change this to whatever you want. We can make it count by 5's, 1, 6, 11, 16, 21. And notice it stops at 21 because if it were to loop again, adding 5 to this would be 26, and that's higher than the 25. So it's not going to go over this max number. You can even make this into a decimal. And it'll go like 1, 1.5, 2, 2.5. See? 1, 1.5, 2, 2.5. It'll count up by half to get to 25. However, if we make this too big, like I want to start at 1, go up to 25, but I want you to count by 50. It's only going to print it one time. Because the first time it starts off at the starting value, okay, that's fine. But the second time you add 50 to it, 50 plus 1 is higher than the ending point, so it's not going to print it. If you increment by a negative number, that's just not even going to work at all because you'll never get to 25 by adding a negative number to 1. But what you can do is start at a higher number and then go to a lower number. In this case, well, actually you have to use a negative number because how else will you get from a 100 to 0 without using a negative number? 100, 95, 90. See? Something you can do with loops is end it prematurely. For example, if you want to stop this loop from looping whenever, I don't know, base plate transparency is equal to 0, we can write an if statement. If workspace.baseplate.transparency is equal to 0, then the way we end the loop early is break. And basically break looks whatever loop it's inside of. In this case, it's all encased in this for loop. Even the if statement is encased in it. Then it will stop the for loop early, no matter if the I value has reached its end goal or not. It'll stop it, and then the script will move on with whatever else is going on later in the script. So what it's going to do is going to start at 1. It's going to set the I to 100. Going to wait a second and print it. And it's going to check, hey, is the base plate transparency equal to 0? And then if it's not, it'll just keep going again and loop it. This time subtracting 5. Wait a second, print it, and it's going to check again. Every time it loops, it's going to check it again because we put this if statement inside the loop. So anything we put inside the loop will happen every iteration or every time the loop is looped. And I'll show you that in action. As you can see, it's working fine because the base plate's transparency is equal to 0.5. So it's going to be looping just fine until the transparency is equal to 0. And you see, it printed the 40, then it checked the base plate's transparency. Oh, the base plate's transparency is equal to 0. And we told it if the workspace transparency is equal to 0, then break out of that loop. And now it's broken out of that loop. And even if we change it back, the loop is done. It's over. Forget about it. It already broke out. It's moving on to the rest of the script, onto bigger, better things.